So let's go ahead and work on number 2. You have the first product, and then you have a second product. Hopefully you guys have done this reaction before. All right, so let's go ahead and take a look at this. So this is a tricky step because your SN2 does not happen right away. What is NaH? Does anyone know what that's called?
Is it sodium hydroxide?
Not hydroxide, because hydroxide's OH.
Oh.
You're close. It is sodium hydride. So when you have a metal, what does that mean about what it's attached to? Any other time we've come across a reagent that has a metal in there? Is that metal charged or is it neutral? It is charged. It's Na+. So what does that mean about the hydride?
It's negative.
It is negative. All right. We are going to take a small interlude to talk about this because this is very important. What are the differences between these three things?
The charge.
Well, that's, yeah, something. What's causing that charge? I guess I should be more specific.
The electrons.
Yep. 0 electrons, 1 electron, 2 electrons. Protons, 0 electrons. We think about those when we think about acids. These essentially are what being thrown back and forth. Hydrogen is my neutral element. Hydrides, H- has a lone pair. These can either work as nucleophiles or bases. More often than not, we are going to use them as bases. So if you see sodium hydride, what reagent should you immediately think? Just told you.
Minus.
Nope, I said what reagent? What type of reagent should you think? It is going to act as a base. Base. No matter when you see sodium hydride. So I'll try this again. When I see sodium hydride, what type of reagent should you think about immediately?
Base.
Base. It is a base. All right. This is very important. You need to know that sodium hydride is a base. So let's go back here. So now coming back to our practice exam. Your practice exam. This isn't my practice exam. What is this going to do here? My sodium hydride. What is this going to do?
Attach to like.
It's not going to attach. Do bases attach?
Does it break the triple bond?
Nope. What do bases do? Think about, don't answer anything else. What do bases do?
Accept.
Accept.
Protons.
They accept protons. Yes. Okay.
Protons.
Don't forget your basic chemistry. This is something that a lot of organic chemists do because you guys are starting to differentiate out into biochem and biology. And so, and you also want to put Gen Chem in the rearview mirror because you have horrible memories of it. But don't forget your basic chemistry. Sodium hydride is a base. It is going to look for acidic protons all day, every day. So where is the acidic proton in this molecule? Whenever you have a terminal alkyne, that carbon on the outside has a hydrogen. That is an acidic proton. So when you see an alkyne at the end, it's the same. I'm going to draw this out here. So this pH is coming down to CH2, to a carbon, triple bonded, to a carbon connected to an H. That's what's actually drawn here, right? So when you have a carbon, triple bond carbon to an H, this right here is an acidic proton. So now what's going to react with that acidic proton, Gwen?
The sodium hydride.
Yep, and my hydride is just going to grab this like any other base, and it's going to put that charge back here. So now what I'm going to get is lone pair like that, and there's going to be a negative charge because now it's going to be a nucleophile. Does that make sense? Okay, so then in the second one, it's just going to act as an SN2. So it's going to attack the carbon with the bromine, pop that off. So then I'm going to have pH coming down to this triple bond, and then I'm going to add 1, 2, 3 carbons because there's 1, 5, 3, 2, 1, 1, 2, 3 like that. So that should be my final product. Does that make sense? Questions on that? Now's the time. Okay. Let's take a look, scroll down to our next ones. So go ahead and do 4, 5, and 6. I'm gonna go grab myself a drink of water because I am thirsty. I'll be right back. How's it going? Okay, so for number 4, we have our, this is our nucleophile. So just draw our product. Every other stereocenter stays the same because we're not going to get involved in this reaction. But now we should have on a wedge, because it's SN2, SCH3. We invert. Is that what you guys got? Okay, any questions on that? All right. And for the next one, we have to figure out what the substrate in the nucleophile is. So in this type of problem, you're just are going to look at your product, right? So any ideas on this one? What are you guys thinking? Or no ideas?
Would you recommend trying to like draw out the product? Or you think it's easier to figure out this way?
You can, so yeah, if you want this, sometimes this is useful if you want to draw it like this. I think this is what you mean, like this, right?
Yeah, yeah.
Okay, so what type of chemical is this? What family of reagent is this? Don't all answer at once.
Isn't it the one where you have to like?
It's an ether.
Oh.
So this is an ether. So if you ever get a problem, and you want to pay attention to this, if you ever have to synthesize an ether, you just pick one side. You pick the side that has the smaller attachment. So find your oxygen and imagine that you can cut either here or here. So if I cut on the purple side, right? If I cut on the purple side, I would get this, right? Right, because I'm just cutting, I got rid of this part, that middle chain. If I cut on the black side, I would get this, right? I cut that bond. Do I get different things or is it the same thing? I have an ethyl and then this thing. I have this thing and an ethyl. So are they the same or are they different?
They're the same.
So does it matter which side I cut on?
No.
No. Okay, so this is what you do. If they were different, you would pick the one that was smaller without the oxygen. So imagine you had like an ethyl, but on the other side you had just like a methyl. You would cut so you only have the methyl. You cut to get the smaller side. So here, I will show you what I mean. I'm going to go to this page because this is what I mean when I'm saying. So imagine now instead of that one, we had this. Which side would I cut? Would I cut on 1 or would I cut on 2?
1.
1, because imagine this is CH3, right? So if I cut on 1, I get a CH3 by itself, and then I get the O like that, right?
Yeah.
And so you always, always, always want to cut it so that you can get the smallest little piece without the oxygen.
Okay.
Because if you cut 2, what you would get would be this plus this, and this is an ethyl, right? So this one is bigger, so then you don't want this one. You want this one. Does that make sense?
Yeah.
Okay. Hopefully Dr. Dewis won't give you that type of problem, but this is just for your information to store for later. So going back to our problem at hand, it doesn't matter which side we cut on, right? And I'm going to go draw that again. It doesn't matter if we cut to the right or to the left. So all you do is that I say I'm just gonna cut to Mags. Which way do you want me to cut? To the left or to the right?
The right.
Okay, so I'm gonna cut here. So the side with the oxygen becomes what? The nucleophile or the substrate?
The nucleophile.
Yep, it is going to be the nucleophile. So you can either write it as that O minus, or you can write it with a sodium if you want. Essentially the same thing. All right. The other side, right? It's going to be it's going to be CH2, CH3, right? Because we got rid of this bond here. So what do you think you're going to put on this side to give it 4 bonds? What do you add to that side that got cut? What would make it a good electrophile? A what?
A halogen.
Yep, a halogen. So just add something like Br. Like that. Does that make sense? So a way to think about this, I'm going to go back to here on this whiteboard to give us some space, is that if you have something like this, decide where you're going to cut. And just imagining on the left side with the side with the oxygen, you add a sodium. The side without the oxygen, you add a halogen like that. Yes, OMe is the same thing. No, it's OET. There's 2 carbons. Yeah, but yeah, you got it. Any questions on that? Okay. All right, and finally, let's do the last one. Hint, this is an intramolecular SN2 reaction that forms a cyclic ether. So I'm only gonna give you 30 seconds because you guys should be old pros at this. All right, so you guys remember the advice I gave you about intramolecular? Or is it all slipped out?
Count the carbon chain.
Yep, just count the chain, find your nucleophile, in this case oxygen, then count the carbons. 2, 3, 4, 5, 6. So you're going to have a 6-membered ring with an oxygen. So 0, so oxygen, 1, 2, 3, 4, 5, 6. And that's what my product should be. Does that make sense?
If there isn't a hint saying that it's an intramolecular SN2 reaction,
All right.
How would you know?
So going back to the other ones who have been here this week, how would you know that this is an intramolecular if there's not a hint?
It's like incorporated in the thing. And like
how many reagents do I have?
2.
Nope.
Wait.
All
0.
I have is 1. If I only have one thing, the only thing that can happen is intramolecular. Right?
So it'd basically be like if you took away the hint and the arrows, if that's all you had was just the chain and the reaction arrow. Okay.
Mm-hmm. Yeah, because do you have anything over your arrow? No, right? Because normally when you have something like this, right, you normally have this and then you have like some sort of like nucleophile or something, right? In this case, you don't have anything over that. So then that tells you that this is probably going to be intramolecular. That's your key indicator, that you only have one thing. That's not always true, but that's the easiest indicator. Especially for you guys, where you guys are at right now. That's the level of vocab I'm going to give you. so as not to confuse you. All right, draw the mechanism for the following SN1 reaction. Show all 4 reaction intermediates. Use curve arrows to show the movement of electrons. So you have 4 different intermediates. I'm gonna give you guys a couple minutes. I'm gonna pause this so that we don't have extra time on the recording. Godspeed, resume recording. So for those of you coming back, I just was mentally abusing these guys that are here because why not? So what type of reaction is this?
SN1.
And it tells you, right? So what is the first thing that happens? Did you guys just read that or did you know that?
We read it. Well, I read it.
Okay, so what happens in the first step of an SN1 reaction?
The halogen leaves.
Yep, my leaving group goes bye-bye. So this is going to go up to here like this. Okay, so now I'm going to be left with so what have I formed?
Carbocation.
What type of carbocation?
Secondary next to a tertiary.
It's secondary next to a tertiary. But so what is going to happen? What is the R word that I have to watch out for?
Rearrange.
Yep. And what is also the key indicator that something is going to happen, like something that's going to change?
A ring.
Your ring goes from 5 to 6. That is your biggest indicator. So I'm going to just scroll on down and give us more space because I didn't go all the way down. So coming back to here again. So we had this now. Okay. This is my carbocation. So what is going to happen now is that we have to have some type of rearrangement, right? So since our ring is a different size, what are we going to do? Hydride shift, methyl shift, or ring expansion?
Ring expansion.
Ring expansion, yep. So this is going to be carbon 1, 2, 3, 4, 5, 6, 7. So right now, in order to make my carbon go from 5 to 6, I have to add 1. So I am going to shift the bond between 3 and 7 to 3 and 2. No, sorry, to 7 and 2. So it's going to be, it was between 7 and 3. Now it's going to be between 7 and 2. So now I just draw a 6-membered ring like this. And there should be a methyl coming off. So now 1, 2, 3, 4, 5, 6, 7. Which carbon lost the methyl group? Carbon 3 is going to be my carbocation now. Now, what type of carbon is that? Primary, secondary, tertiary?
Secondary still?
It is the secondary next to a tertiary. So I'm going to have a hydride shift. And now this is going to be my carbocation. Does that make sense? Okay, so now I have my tertiary carbocation. I have expanded my ring. The only thing I need to have happen, and I'm going to just scroll up real quick to take a look at CH3OH. The only thing that's going to happen now is that the CH3OH is my nucleophile. So now the oxygen is going to attack like this, right? It is going to attack that carbocation. Does that make sense? All right, so then the last thing I have to do is that this is just going to be methyl OCH3, but the hydrogen is still there, right? I haven't lost that hydrogen yet. So now my oxygen's a plus charge. So then what happens in the last step to give me my product? A base will come in or something, right? And take away that proton, and that gives me my final product. Does that make sense? So this is something we saw in the other practice exam. So let's do some strategy here. Do you have everything written down, or are you guys still writing?
Just one more second.
Take your time.
Wait, so the base attacks a hydrogen and then the hydrogen attacks oxygen?
No, it takes the proton and the bond goes back onto oxygen.
Oh, okay.
Remember, when I take a proton away, I'm not taking the bond. The bond goes back on and forms a lone pair.
Because when an oxygen has 3 bonds and 1 lone pair, it's positive. So you have to take away the hydrogen and put the back or that bond to the oxygen to make it 2 and 2.
That's correct. Coal out of nowhere.
Yes, sir.
Coal also very loud out of nowhere.
Oh, really? Sorry.
That's fine. It's just that the other 3 are very quiet. I think you actually have a mic.
Oh, gotcha.
Which it doesn't matter. It's just that it's fine. Yep, and that's it. So can I erase this? Are you guys good? Because I want to talk strategy. All right. So here's how you should approach this problem. Whenever you have an SN1 reaction, and it's this type of mechanism, what you should always do at the beginning of your problem, because this will make your life a little bit easier, is just to come in and take a look at your substrates. See if there's any type of rearrangement happening. And in this case, you know that there is a rearrangement, right? So always think about what happens in an SN1 reaction. So think about in your mind, I have an SN1. Step 1, leaving group leaves, right? Step 2 is optional. This is an optional step. It doesn't always happen, but this is where you have rearrangements. So if you need to do a ring expansion, hydride shift, methyl shift, whatever, this is when this is going to happen after your leaving group leaves. Step 3 is going to be your nucleophile attacks. And step 4, this is again optional, is if your nucleophile is water, alcohol, or carboxylic acid, one of those 3 groups that has an extra proton, you are going to have a deprotonation. You are going to remove your extra proton. And these should be your 4 steps of SN1 mechanism. What do you think of your arrow pushing? Does that make sense? All right, so step 1 and step 3 are always going to happen. 2 and 4 are up in the air. So this is always going to be 100%. Step 1, step 3 is going to always be 100%. Step 4 is like 80 to 90% of the time. It's going to happen more often than not. Step 2, this is really a 50-50. You may have a rearrangement, you may not. It just depends on how your instructor's feeling. But always look at what your structure looks like before the reaction and after. That's always going to be your biggest indicator. So Gwen, do you remember what type of rearrangements we just had?
Yeah, we had a ring expansion.
Mm-hmm.
Hydride shift.
Yes, is that what we had yesterday as well?
Yes.
Yes, so it looks like Dr. Dewis may have a style. I'm not saying that that's what she's going to do, but on multiple exams, she has had 2 types of rearrangements in the same mechanism problem. Ring expansion followed by hydride shift. Think about that. Remember that. Commit it to your memory. All right. Questions on that? Are you guys feeling good on that one?
Can you leave the steps up real quick?
Yep. And real quick, if you notice here, what acted as your base in this problem?
The
Bromine.
The bromine. Yep. So sometimes that indication of what acts as a base will be in there. Does that make sense? Okay. So let me know whenever you guys are ready to go on.
I'm good.
Morgan, you good? Max, Gwen?
Yep.
Okay. Okay, draw the mechanism for the following addition reaction. Show all non-zero formal charges. Show all reaction intermediates. Use arrows to show electron movement. So go ahead and start on this one. I'll give you guys a couple of minutes. Physics, I enjoyed physics. It did take a lot of work. That one probably took the most time because I did a lot of practice problems. I went to the physics library at UW, and I would sit in the library for 4 or 5 hours every day just doing practice problems from the textbooks, because there's only so many ways they can ask you questions. So, but before this ends, because we're about to end, I'm doing an addition, right? So remember, anytime I have HBr, my double bond is going to act as a mild base / mild nucleophile, right? That's the way to think about this. But when we come back, we will do this reaction mechanism. So I'm going to end this and we'll come back and we will continue on. So I'll be right back.